here we are at the end of the unit. Now, this was the shortest unit that we've had so far, even though linked data is a very large topic. But the metadata aspects of linked data are already more or less familiar to us. RDF triples, objects have properties. Those properties may have controlled vocabularies or encoding schemes behind them that dictate how the values for those properties are chosen. The relationship between the object and the value of the property, that is the subject, is the metadata element describing the object, the predicate. All of these are things we've talked about several times before in the context of different metadata schemas and is encoded in RDF. So linked data, even though it is a more complex use of these concepts, are using all of the same concepts we've looked at already. The world of linked data is a fairly complex ecosystem, but the principles of metadata, I hope you can see, are consistent from the simplest to the most complex. Now, I said before that units 4, 5, and 6 were a sequence of related topics, and now the truth can be told. It was a sequence about interoperability. We started with descriptive metadata and crosswalks. We moved on to structured data and semantic markup. We touched on repositories and harvesting, and we ended with linked data. So what I've tried to do in this 3-unit sequence is work our way up in complexity, looking at different uses of metadata that allow for metadata to be shared across systems, across web services. Now, as usual, there is a lot that we did not discuss in this unit. Inevitably, because this is a large area, linked data has a lot to it, a lot that is not directly relevant to metadata. So again, I tried to stick to just the metadata aspects of linked data, even though there's much more to it than just that. So we looked at the DBpedia ontology, which is based mostly on OWL, on the web ontology language, but I didn't get into OWL specifically. We didn't talk about Sparkle, which is, I think, a kind of hilarious acronym, and it's also a recursive acronym because it stands for the Sparkle Protocol and RDF Query Language. It's a recursive algorithm. Computer scientists seem to like those. They find them funny, I guess. At any rate, Sparkle is a language for querying databases. In other words, it's a language for retrieving and manipulating data that's encoded in RDF. We didn't talk about the Simple Knowledge Organization System, SKOS, which is a W3C specification. It's a model for expressing any controlled vocabulary, any thesaurus, any ontology, any subject heading list, and etc. in RDF. And as we saw in the Berlin example, it's a mechanism to achieve interoperability across schemas. We also didn't talk about the Open Graph Protocol and Twitter cards. Now, the Open Graph Protocol was developed originally by Facebook, and Twitter cards was, I think it should be fairly obvious, developed by Twitter. And both are fairly platform specific, but both are other ways to embed semantic data in web documents and pass it between applications, although largely they're used for passing data between web applications and Facebook or Twitter. But they're related to linked data in the sense that they accomplish more or less the same goal of interoperability, of reuse of data. So, what did we do in this unit? What we did in this unit was we started to analyze how linked data works as an exercise in the use of metadata. And here's how linked data works. You have data. You have a data set based on whatever it is that you do. It could be from your business, it could be scientific data, it really doesn't matter. You have a data set. You have to structure it so that the entities in your data set are of standard types. And that means, usually, using pre-existing metadata schemas. Ontologies like Dublin Core, like the music ontology that we looked at, like friend of a friend, like the art and architecture thesaurus, like the thesaurus of geographic names, whatever. The point is, if you use a pre-existing standardized schema for encoding the types of entities in your data can be combined and remixed with other related data sets. Using pre-existing schemas means representing your data as RDF triples. And then you make your data publicly available for unrestricted access and unrestricted reuse, usually using some flavor of Creative Commons license. So what we've been working up to over these 3 units is increasingly complicated uses of metadata, but also how to leverage the value of the metadata that you do have through interoperability. Now, that's all for today. Good night, good work, sleep well.